Hey Ambassadors, it's Emma. A few weeks ago, Darlene and I went to South Dakota to Rapid City to do a presentation to a bunch of 7th graders, and we recorded one of our sessions as an example to give to you all of an event. It's by no means perfect, especially since I've recorded it. I'm watching it back and being like, oh man, I could have said X, Y, Z, but it is a good example and it has a lot of parts to an event that would be great to include. So I've edited it down to about 13-ish minutes with a lot of fast speed sections and some cuts to various parts. We also did not record the very start of the event, so I did skip over our personal introduction, so hi, my name is, as well as the definition of citizen science. I do recap it at the start of the recording though, so hopefully that is okay and enough for you. If you need more though, we'll likely make more of these anyhow. And the other sections of the event that we included are things like examples of how to be interactive, examples of how to introduce a project, participating in real time, how to share a follow-up opportunity, and other things. So hopefully this is helpful, and you can always look at the rest of our YouTube channel for more examples. The SciStarter live events in particular go through the process of, hi, my name is, this event is a SciStarter event, what is SciStarter, what can you do to get started? And so those are really good videos to also look at for especially the beginning of the actual event. So we will make more of these. If you have comments about it, if you have questions or feedback, etc., feel free to send us an email about it too. But for now, enjoy the show. Okay, so we talked about different types of science and how it might have projects involving citizen scientists. So what we're talking about here is scientists can't be everywhere at once. They can't take pictures of every piece of wildlife on the planet Earth. They don't have all the perspectives to be able to try different things. They don't have local knowledge. You all have very specific local knowledge, specific to Rapid City, specific to South Dakota, and that's really, really useful and very helpful for scientists who may have no experience being here. People who study Australian wildlife don't necessarily live in Australia. They might be living somewhere else and they're trying to impact wildlife and help wildlife in Australia. Have we ever heard of the term conservation? Conservation, I hear you. See one hand. Anyone else? Conservation? Do you have any idea what that is? We have one person who knows what that is. I think that's not true. What does it mean?
I think it means to like keep safe.
Yeah, it's to keep something safe. It's to keep it maintain its existence. And so when we're talking about conservation, we're talking about the black-footed ferret. There's very few of them here, and there's a bunch of them here. So there's a lot of efforts to conserve the black-footed ferret here. We're trying to make sure that they can stay around for long periods of time. And as far as science goes, all the different topics that exist in it, there's a citizen science project for it. Now, on the screen, this is what SciStarter is. So this is what Darlene talked about earlier today, and she is the founder of SciStarter.org, where we aggregate, which means we bring together all the projects that we can that are quality projects that you can help benefit and improve the science of. So from like health and human medicine to astronomy projects to conservation projects and wildlife documenting, those are all things that you can actually take part in to actually impact real research. And so as a SciStarter user, you can go on here and just write in penguins and find like 12 different projects. You can write in stars and find 50. Like there's so many astronomy projects. I love them. They're awesome. You can go on there and look up the black-footed ferret and probably find something. It might be a little bit too specific, just ferret might work. And so there's all these projects that you can take part in, and that's what we're here to help you do. But we're also going to actually do a project today. So in the next slide, has anyone been out of the country? Oh, awesome. Okay, this is the biggest group. Has anyone been to London or the UK in general? Really? Okay, cool, awesome. So if you've ever been to London, there's an area there. It's called the Zoological Society of London. Anyone been to a zoo?
I don't know.
In Sioux Falls, a zoo where you see animals hanging out. Okay, so if you've been to a zoo, the Zoological Society of London is a giant zoo, basically. It has a bunch of different sectors of it. So it's like there's a zoo part, there's a research part, and there's an education part. As a part of their programming, they work with citizen scientists. So there's a couple of things to know about it, though. If you've ever seen a nature documentary where you've heard a very lovely British male voice talking to you about the glory of Earth, if that sounds familiar to you, his name is David Attenborough. That man, he hangs out at the Zoological Society of London and really helps it run and is a part of the process of like making it as effective as it is. Anybody watch Winnie the Pooh? Yeah, Winnie is actually a real bear. This bear existed. Like 100 years ago, there was a bear named Winnie, named after Winnipeg, which is where they found the bear, and shipped it off to London. They shipped this bear to London and hung out in the Zoological Society of London, hung out in the zoo, and Christopher Robin, a real person, a real boy, went to the Zoological Society of London Zoo and hung out with the bear, and then Winnie the Pooh was born. They created that program. So this is a very historically significant zoo. They are a big deal. They've been around for hundreds of years, 200 plus years, I believe. And they were also helping with the theory of evolution, if that sounds familiar to you all. They worked with Charles Darwin to develop the theory of evolution. They're a big deal. And as a part of their work, they also help us be a part of the process. So we're going to actually do a project that you heard about earlier today. So earlier today you heard about multiple different locations across the world where you can look at camera traps. Does anybody remember what a camera trap is? Camera trap. What does it sound like? Okay, turn to your neighbor. You have 15 seconds. What's a camera trap? All right, what's a camera trap? Raise your hand if you know, or if you have an idea. You don't have to know what it is, but what do we think it is? Yes. Yeah, a camera that when it detects motion creates a picture. It takes a picture. That was a perfect definition. Yeah, absolutely. So these camera traps are all over the world, and the Zoological Society of London takes all these images coming in from all over the world and puts them into this database for us to help them analyze what animals are present. So we have the option of going to multiple different locations. Does anyone want to choose a location for us? Or we can raise our hand. So if you want to go to Kenya, raise your hand. Okay. Do you want to go to Costa Rica? Raise your hand. Ooh, okay. Do you want to go to Borneo? Do we know where Borneo is?
Mr. Johnson wants to know.
Okay. I saw most hands for Costa Rica. Are we okay with that? Okay, cool. Let's go to Costa Rica. Why do you think they have a Costa Rica project for camera traps? What is going on?
Maybe there might be like endangered animals there and they need to make sure that they're like still alive.
Exactly, yeah. So when we take camera trap images, it means that we can go through and see what animals are around. They're moving around, they're going past the camera trap, taking pictures when they move by, that motion sensor. We get to see what kinds of animals are passing through, and oftentimes their behavior too. And so we get to learn a lot about what these animals are doing. We get to see a lot of ones that are not endangered. They're just totally normal, least concern animals, because we'll see a lot of them happening. But then on occasion we find these pictures of animals that do need our help, and we do need to evaluate what are they doing, where are they going, how many of them there are, because we need to be able to figure out how to conserve them, how to do conservation practices. So in Costa Rica, there are a lot of different animals. Notice at the top here, there are 24,000 pictures. Woo, hooray. 24,002 have been identified. Anybody use like AI and ChatGPT and other things? You're familiar with it? Okay, cool. I do too. I love it. Anyway, not the point. The point is that why don't we use AI for this? Do we use AI for this? Do you think AI would be helpful? Yeah, it is, and it is actively used. And so a lot of these images, some chunk of this might have gone through an AI system to be able to identify what these animals are. However, is AI perfect? No. What are some problems with it? Anybody know? What are some problems? Yeah. Do we have to teach AI, or is it know everything?
No.
We have to teach it. We have to give it information in order for it to figure out what's happening. Like it has to be able to respond to a database. And so as much as we love databases, our databases may be full of pictures of things that are very clear. So if you see this nice leopard, do you think there's any challenge for an AI to identify that this is a leopard?
Yeah.
It's just a leopard. Like it's very, very clearly a leopard, or at least it could be very clear if we gave them examples of pictures of leopards. This may be one of the best pictures we have. And so because there are really good pictures, we also have pictures taken at nighttime, or taken and the animal's like running by where it's blurry. And so AI looks at that and says, don't know what it is, or they give us random answers that are not actually true. And so instead of going with AI, which is just not smart enough, we need to use our human eyes to actually identify what these animals and different organisms are. And so that's why we got 29 left that need us. Okay, so we're going to go through and actually try to identify some of these and see what we can find. So again, this is in Costa Rica on the Osa Peninsula. And I'm going to scroll through and just click one that has an animal on it so we can start strong. Okay, so we're looking at this thing. Anybody know what it is right off the bat? Yeah, what do you think? A squirrel. I think that tail might be a little too long to be a squirrel and not puffy enough, but that's a good start. So we're looking at maybe a small or medium mammal. Would you mind hitting the small, medium mammal?
Oh, yeah.
Yeah, sweet, thank you. So if it's a small, medium mammal, that's great. So now we can narrow down the options here. What do you think it is? Spider monkey. Well, it's got a slight curve in its tail. That's very true, but I don't know if it would be. It doesn't exactly have the hands.
Who said that? I would have thought that too, because they're all over the Osa Peninsula.
Oh, are they really?
But it's not showing it as an option, so would that mean it's not one?
What do we think? Yeah. A lemur. Okay, so we're looking at lemurs, maybe. Yeah, so let's see what these examples are. If you scroll up to the top, let's see what it says. Oh, okay. So we start with a white-nosed coyote and a silky anteater. Okay. So I'm gonna look at this tail. I'm gonna say that this is a pretty skinny tail, so it's not gonna be like super fluffy. Okay. So when you look through these examples, like these are both not very fluffy. Honestly, this one's a little bit more fluffy. But as we scroll down, if we see something like this, really fluffy tail,
tail, no tail visible, little tiny, we know it's not those ones. So we can kind of narrow it down in our own brains. But what are we looking at? Wrong type of tail. What about this guy? Is that a tail here? Or raccoon tail? Raccoon raccoon? That raccoon eats blood. We got squirrels, we got raccoons. Does this look like a raccoon tail? No. No, why not? What do we expect to see on a raccoon tail? Yeah.
Do I have like kind of short, stubby, or something?
Fluffier, yeah, usually. I don't know about short per se, but I did hear someone say like stripes. Someone say stripes? Did I make that up? Okay, someone said stripes. I heard something. And so this doesn't look all that striped, and oftentimes raccoons tail straight. Yeah. So inside we're looking at other things. We got a long tail. Its body is pretty like I don't know, proportional. What about its face? Ooh, cool. What about this? Do you see the nose? See the shape of the nose? Oh, what does it look like now? Yeah, what do you think? It might be an here. So if I do that and magically move, oh gosh, this is awesome. Okay, so I'm looking at this face now. Look at those faces. They look like they're pointed. Does anyone have a preference on which one we click? I think those are the only two of those faces. I mean, I guess these raccoons have a bit of a push, but it's not very significant. What do we think? Anyone want to have a guess? A face I found quite handy. The silky anteater. Okay, yeah, who agrees? Okay, that's a good chunk of you. What else might it be? What do we think? We just think it's that. We can click on that one. So I'm gonna go and hit tag. Wow. Except I'm not gonna hit tag because somehow it didn't work. Tag. And it allows me to say, okay, one of these things. I'm looking at one. I don't see any other animals in here. What if we're wrong?
Try again.
Well, do we know it's wrong? We might be the first ones to look at this image. Will we know we're wrong? No, that's part of our job. We're trying to identify what it is. So we don't know the right answer. Do you think scientists take our word for it?
No.
No, why not?
Because they might have to have like other people might have like different opinions. So they
Yeah.
have to like make sure like
Totally.
it depends how many.
Yeah, you're there. You're exactly right. It might depend on how many people participate in this, right? So we might have a bunch of people participate in this. I am using more of you, right? I'm using more of you to get my answer, but that doesn't mean this is the right answer. Like we're using the crowd in one room, but we might still be wrong. And so I'm gonna go ahead and hit confirm identification as the first person to do this, but there's gonna be another 10 or so people who will look at this. We have a new picture. What do we think about this one? You look like you're really looking at us. What do you think it might be? Red-shirted friend.
His face looks like it.
Yes.
No idea?
Armadillo.
Does it have a tail?
Yeah.
Yeah. Is it like a small or medium mammal?
Small, medium.
It's a small medium mammal, I think. It's not a giant cat or anything. You can also tell that it's at night, it's kind of dark, it's facing the wrong way. Can you tell that AI would have difficulty with this?
Yeah.
Yeah, it might have a lot of difficulty. We have difficulty with it. And so if we are like still unsure, we're still guessing, that's okay. Because we're still better guessers than AI. And so I'm gonna go ahead and hit tag, although it's not working. And then I'm gonna hit confirm identification. So we can keep doing this, and there's only 29 images left in this. So if all of us went home today and did this project, that would be 10 plus people per observation. We would finish this data set. These Osa Peninsula researchers who are looking at wildlife and endangered animals out there are going to have all the data that they wanted from this data set within a day if we were doing that, okay? So if you want to go home and do this project, you absolutely can. Let's talk about what else you can do. So we've been to Costa Rica. This is one conservation project. In those lovely bags of yours, you received 2 different items that were from us. One of them is a postcard, and the other one is a little little business card that has the Big Moon project on it. Oh, if anyone's a postcard, hold it up if you have a postcard or one of the other things. Yeah, perfect. Yay, can I borrow it? Okay. So this postcard says 1 million acts of science, starting on April 1st. Starting on April 1st. If you went onto our website, the SciStarter.org, or you scanned this QR code on the back, you can sign up to do projects and participate in a global effort to get to 1 million acts of science by the end of April. Last year we made it on the 24th. Maybe we should get to the 23rd. So if you can help us, we can get there even sooner. And it'll be really fun. So you can do all kinds of projects. It doesn't have to be conservation. You can go and look at images from NASA, looking at telescope images to figure out where clouds are on Mars. You can look for faraway galaxies. You can just figure out where light pollution, how bad light pollution is in your area. There are so many different types of projects you can participate in, and it'll all count towards this 1 million acts of science goal. Each one of these each one of these identifications I did, that was 1 act of science. So if you did 29 with the 29 images left later today, that's 29 acts of science you can say you did. So that's all of April. Okay, we feel pretty good? Awesome. All right, before you leave for your next thing, we have stickers for you that I would love to pass out, but I would like help. Would anyone like to pass these out? Sweet. Awesome.